Chapter 8, Gravitation. In the last lecture, we have discussed about universal law of gravitation. Newton's universal law of gravitation. Its scalar form and vector form. But see, if you have observed that law was for only two particles. Again, I will repeat. See, if I have two particles having masses m1 and m2 separated by distance r, okay, then force acting on m1 due to m2, force acting on m1 due to m2, F12 is equal to F12 is equal to you know the equation, that is G m1 m2 upon r12 square r12 capital. Okay, and see, force acting on m1 due to m2, attractive force means it is towards. So force acting on m1 due to m2, it is in this direction. It is F1. Clear about this? Okay. Now similarly, force acting on m2 due to m1, F21 is equal to, it is G m1 m2 upon r21 square r21 capital. Okay, and again force acting on m2 towards m1, it is in this direction, it is F21. Okay, so yes, we know vector form of universal law of gravitation. How to write equations for two point masses. Clear about this? Okay, and yes, from figure it is clear. Okay, F12 is equal to minus F21, which is nothing but Newton's third law of motion. Means universal law of gravitation obeys Newton's third law of motion. It obeys Newton's third law of motion. Clear about this? Okay. Now see, yes, it is for two masses. But if you are given more than two particles, more than 2 point masses, then how to find gravitational force? See, it is called superposition principle. It is called superposition principle. Yes, it is called superposition principle. For example, it is coordinate system x, y, z perpendicular to what coming outside. It is point O. If you are given numbers of particles having mass m1, m2, m3, m4, for example, there are 4 particles having position vectors r1, r2, r3 and r4. And now if you have to find force acting on any one particle, then how to find such force? We are assuming we want to find force acting on M3. Okay, the gravitational force, okay, which is attractive. Okay, attractive force on M3. How to denote this? See, on M3 means you have to find force on particle number 3, F3. Now one simple question. In universe, every object attracts another object. So, you are given 4 particles, M1, M2, M3 and M4. So yes, M3. We have to find force acting on M3. So other particles are M1, M2 and M4. So simple. On this M3, attractive force is acting due to M1, due to M2 and due to M4. Yes or no? Yes. Then how to write as equation? Force acting on third particle is F31. Force acting on third particle due to 1 plus force acting on third particle due to 2 plus force acting on third particle due to 4. Simple? Hello? Okay. So force acting on third particle is due to 1, due to 2 and due to 4. Now how to write the equations? That will go okay. F3 is equal to it is G M3 M1 R31 square R31 caret. Yes or no? Yes. Plus G M3 M2 R32 square R32 caret. Okay. Plus G M3 M4 divided by R34 square R34 caret. Easy. Okay. Now see, here it is. In these 3 terms, G and 3, G and 3, G and 3 common. So I can write it like this. Okay, F3 is equal to it is Gm. In bracket, here it is M1 upon R31 square R31 caret. M1 R31 square R31 caret plus M2 R32 square R32 caret plus M4 R34 square R34 caret. Clear about this? Okay, how to write this equation? Okay, how to write this equation? Okay, now see in bracket, observe each and every terms. M1, M2, M4. R31 square, R32 square, R34 square. R31 caret, R32 caret and R34 caret. So I can write this bracket having sum. Okay, yes, it is nothing but one type of sum. Then how to write this? See, F3 is equal to G and sigma I is equal to 1 to 4 because you are given total 4 particles. But I is not equal to 3. Why I is not equal to 3? See, here there are terms having 1, 2 and 4, not above 3. So how to write this? M I. Why am I? Because M1, M2 and M4 divided by R3I square. 3 1 square, 3 2 square, 3 4 square. R3I caret. R3I caret. Now see what is meaning of this sigma. I is equal to 1 to 4. Means you have to put 1, 2, not 3 and 4 instead of I. So first of all 1, 1, 1. Then first term. Then put 2, 2, 2 and 2 and second term. Then put 4 directly. Okay. 4, 4 and 4. So you will get your answer. Okay, so yes, it is called superposition principle. It is called superposition principle for vector addition. For vector addition. Clear about this? Clear about this? Okay, so yes, if you are given numbers of particles, system of particles, and you have to find force acting on any one particle, then how to find? Simple. First of all, find individual forces. First of all, find individual forces. Okay, a force on 3 due to 1, then due to 2, and then due to 4. And then take their vector addition. Take their vector addition. Because force is vector quantity. Force is vector quantity. Clear about this? Okay, so here I will write statement. A resultant gravitational force acting on a particle is vector sum of forces acting due to individual particles. Clear? So yes, you have to remember this statement. Clear about this? Okay? So yes, it is for two particles. It is for more than two particles. So remember what is difference between them. Okay? Next. Okay, now next title is, see, gravitational force due to holospherical shell of uniform density. Yes, shell and sphere, they both are different. Okay, shell means mass is only on its surface, Okay, so yes, if you are given gravitational force, if you are given spherical shell, then how to find force, attractive force, gravitational force? We will consider two cases. First, if point mass is situated outside shell, like this. See, if it is shell, it is in center, and yes, point object is here. Point mass is here. Then your question is, what is attractive force? What is attractive force on this point mass due to this hollow spherical shell of uniform density? Okay, question. Find gravitational force, attractive force on point mass due to this shell. Okay. See, this shell. We know Coulomb's law for, we know Newton's law for 2 point masses. Then how to find due to such a shell? Again, we know one equation, that is F is equal to G m1 m2 upon r square. F is equal to G m1 m2 upon r square, but it is due to point masses. Yes or no? Yes, it is. Then how to find force between one shell and one point mass? See, I can assume this shell to be made up of numbers of small elements. Clear about this? I can assume this shell is to be made up of numbers of small elements. Okay, I am taking one element here. Okay, of some particular mass. So first of all, I will find gravitational force on point mass due to this. Obviously, gravitational force acts on line joining two particles. So that force acts on the line joining two particles. Attractive means force is acting on these. So it is towards. Towards means in this direction. Yes, it is force. Yes, it is force. Okay. Now this force, it is in this direction. I can resolve this force into components. One in this direction, one in this direction. Simple? Yes or no? Yes. So what is procedure? What is method? First of all, on spherical shell, take one small element, means like point, at this point. Find force due to this element on this point mass. It is in this direction. Resolve into components. Easy. Yes, 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 it is easy. Now, take another element of same mass at its opposite point, this side. Okay, yes, see, distance is same. Distance is same. From this angle is also same. This angle is also same, for example. Okay, and you have to consider same mass. And you have to consider same mass. Then what happens? Now find force acting due to this on this point mass. So obviously it is again on line joining. It is on line joining this. Okay. Again resolve this force in two components. One in vertical direction and one in this horizontal direction. Clear about this? Okay. Okay. Now see, as distances are same, as masses are same, so according to F is equal to G upon M2 upon R square, magnitude of force is same. Magnitude of force is same. Angle is also same. So yes, these two components, observe carefully, these two components, they are of equal magnitude and in opposite direction. Yes, these two components are of equal magnitude but in opposite direction. So these two components will cancel out effect each other. These two components cancel out effect of each other. Then remaining components are only this. And see, these two components are towards center of Earth. Are towards center of Earth. So resultant force is towards center of Earth. Clear about this? So here I will write statement. Okay, here resultant force on point mass due to hollow spherical shell. Here resultant force on point mass due to hollow spherical shell is towards its center. As if it is acting towards its center, as if it is towards its center, as if the whole mass of cell is to be concentrated at center of cell. This force is acting on point mass such that force is acting on point mass towards the center such that the whole mass of shell is to be concentrated at center. Its center. Clear? So now if you take any shell and point is outside, so simple. On this point, force is acting towards its center. So we can say a force is acting such that the whole mass of shell is to be concentrated at its center. A force is acting such that whole mass of shell is to be concentrated at its center. Clear about this? So this first point you have to remember. Okay, if point mass is situated outside the shell, the force on point mass is towards its center, such that its whole mass is to be concentrated as its center. Okay, here resultant force on point mass due to hollow spherical shell is towards its center, as if the whole mass of shell is to be concentrated at its center. Clear about this? Now second point, if point is inside, second point, if point mass is inside shell, again it is shell. Now to understand this concept easily, okay, I am taking point mass at exactly center. It is point mass. Okay, now again I can divide this spherical cell in numbers of elements. I am taking one element here, another element diameter in the opposite point, one element here, another element here. Okay, now just find direction, because see, I am taking these elements of same mass. Okay, these all elements are on surface, so distance is also same. If mass same, distance same, value, magnitude of gravitational force is also same. So you have to just identify direction of force acting on this point mass due to this element towards in this direction, okay, on this element towards, yes, attractive force means towards. Okay, so see, these two forces are of equal magnitude and opposite direction, so they will cancel out effect of each other. Yes, these two forces are of equal magnitude and opposite direction, so its effect is again cancel out. Now you can assume each and every element on surface of earth, see, on surface of shell, cancel out. So yes, if point is inside, force acting on it is zero. Hello, if I put point anywhere inside shell, the same thing will happen. Okay, resultant force. In case if point mass is at not center, then yes, due to each and element you have to draw force vector, take their components and then find the resultant. See, here we have considered components. So yes, similarly you have to take components and then find its resultant. You will get your answer 0. Okay, so force is equal to 0 at every point inside spherical shell. F is equal to 0 at every point inside spherical shell. Clear? Okay, so yes, you have to remember these 2 points. Okay, if due to spherical shell of uniform density, point is outside and point is inside. Yes, these 2 cases are important. So take care about this. Clear? So yes, this is it for today. Next topic, next day.